Okay, ladies and gentlemen, this is the fourth and final video for Chapter 0, Section 2 of your Algebra 2 textbook here. It's a McGraw Hill textbook. This particular video is going to cover how to use the FOIL method to cover polynomials that are larger than binomials. We actually have to do a name change first. Instead of calling it foiling, we're going to rebrand it, if you will, to be called double distribution. Now, why is it called double distribution? It's really the same thing we did. We're making sure that every term in the first polynomial multiplies every term in the second polynomial. So essentially what we do is we rewrite the problem to make sure that we take the first term in the first polynomial, which is 3x, and we multiply the entire second polynomial by that, which is x squared plus 2x minus 4. And then we make sure that the second term also multiplies the entire second polynomial. So negative 4 times x squared plus 2x minus 4. Now, everybody in this course should know that that means we're going to distribute. So if you notice, what we did was we distributed this backwards to each term. And now we're going to distribute those terms through their individual sets of parentheses. So we'd have 3x times x squared plus 3x times 2x plus 3x times negative 4 minus 4 times x squared minus 4 times 2x minus 4 times negative 4. So all we're doing there is we distributed once, and now we're distributing again. Right? That's what we're doing. We're double distributing. So that would give us 3x cubed plus 6x squared minus 12x minus 4x squared minus 8x plus 16. All I did there was multiply each of these monomials. Then we look for like terms. We should have a couple sets in theory. We have two sets, and we add those together. So our final answer would be 3x cubed. We have a 6x squared and a negative 4x squared, so plus 2x squared. Negative 12x minus 8x is minus 20x. And don't forget the plus 16. Done. So we're going to do a couple more examples of this. Looks like 3 over 2 slides. Again, at any time you think you've got this, you could pause the video and try the example and then watch the video to see if you did it right. So, example 2, we're going to distribute. So we say 3x times the second polynomial, 2x squared plus 3x minus 4, minus 4 times 2x squared plus 3x minus 4. And then we are going to distribute again. We're going to distribute a second time. We're going to double our distribution. So that's called double distribution. So that would be 3x times 2x squared plus 3x times 3x plus 3x times negative 4 minus 4 times 2x squared minus 4 times 3x minus 4 times negative 4. Multiply each of those out. That would be 6x cubed plus 9x squared minus 12x minus 8x squared minus 12x plus 16. Watch your signs very carefully, please. And then combine like terms. So we need to add the x squared terms and the x terms together, giving us a final answer of 6x cubed plus 1x squared minus 24x plus 16. Now, this next example is 2 trinomials, which means the problem is going to be bigger. Because the first time, we're going to say, okay, we have to do the first term, x squared, times the second polynomial, x squared plus 2x minus 4, plus the second term, 4x, times the second polynomial, plus the third term, negative 5. Times x squared plus 2x minus 4. So each term in the first set of parentheses times the second set of parentheses. Then we distribute. So boom, boom, boom. Second set of distribution happens. That's our double in double distribution. So we have, and I'm going to write it out, and again, you don't necessarily have to write out this whole step. I'm trying to show where everything comes from. So we have x squared times x squared, and I screwed up, so I'm trying to make it go back. There we go. Plus x squared times 2x, plus x squared times negative 4, plus 4x times x squared, plus 4x times 2x, plus 4x times negative 4, and if I don't make my writing smaller, I'm going to have an issue. Minus 5 times x squared, I can do this, you can't. Minus 5 times 2x, minus 5 times negative 4. Then we go through and we actually multiply each of those out. That is x to the 4th plus 2x to the 3rd minus 4x squared plus 4x cubed plus 8x squared minus 16x minus 5x squared minus 10x plus 20. Then all we have to do is go in and combine like terms. There are quite a few of them this time. We have 2x cubed terms. We actually have 3 x squared terms. And then we have a pair of x terms. So we combine like terms, giving us a final answer of x to the 4th. We have a 2x squared cubed, a 4x cubed, which would be 6x cubed so far. That's all we got, so 6x cubed. We have negative 4x squared plus 8x squared, which would be 4, minus 5x squared would be negative 1x squared. And then we have 16x, negative 16x minus 10x, which would be negative 26x. And then finally, plus 20. One example to go, and again, the point of this last example is to get across a notational issue that is very common in Algebra 2, and that we can't afford to screw up. And that is when we have a polynomial squared. In this case, a trinomial squared. Remember what that means. That means we have to take that polynomial and multiply it by itself. So again, our double distribution is going to ensure that we do that correctly. So we take the first term in the first polynomial times the second polynomial. The second term in the first polynomial times the second polynomial. And the third term times the second polynomial. Then we go in and we distribute each of those. So we have x squared times x squared plus x squared times 2x plus x squared times negative 5. Distribute the 2x. So plus 2x times x squared plus 2x times 2x plus 2x times negative 5. And distribute the negative 5. So negative 5 times x squared, negative 5 times 2x, and negative 5 times negative 5. So we have x to the 4th plus 2x to the 3rd minus 5x squared plus 2x to the 3rd plus 4x squared minus 10x minus 5x squared minus 10x plus 25. Again, we've got lots of like terms in there. We have 2x cubed terms. We have 3x squared terms. And we have 2x terms. So we go in and we combine our like terms. Final answer would be x to the 4th plus 4x to the 3rd. X squareds, we have negative 6 total minus 20x plus 25. This completes the notes for Chapter 0, Section 2.